In this lesson, we're going to talk about the concept of the anonymous function. So let's get started by first opening up a new Python program. So we're talking about anonymous functions. And an anonymous function is a function that doesn't have a name per se, but is based on what's called a lambda form. Now, I'm not going to go into all the details of what lambda refers to. There's a whole history going back all the way to the formation of the lambda calculus back in the 30s. But let us just say that functional programming languages such as Lisp and Scheme and ML have all used lambda as a means of creating functions for years. To understand how an anonymous function works, I need to provide you with a simple example. You remember from the last lesson that we discovered that functions are full objects in Python. So for example, just to refresh your memory, we created a square function, which we've seen many times, and then we assigned it to a variable, like so. What we could do to save us some of the work of creating a function, if we're going to assign it to a variable, is we can create the function as an anonymous function. So let me demonstrate how to do that. We'll use the word square as our variable name. So to create an anonymous function, we first use the word lambda, followed by the parameter that we want. In this case, we're just going to have one parameter, and we'll use x. That's a very common parameter naming technique with anonymous functions, is to use single letter parameters. Followed by a colon, followed by an expression. And that's very important. Let me space that a little bit better. And that's a very important restriction on anonymous functions in Python. You can only create an anonymous function that consists of an expression. If this were an advanced course, I could show you how to get around that restriction using some fairly obscure programming techniques, but for the purposes of this course, we'll stick with the idea that an anonymous function can only consist of an expression. So for example, x times x is a perfectly good expression. And that becomes the body of the anonymous function. So now where we want to use the function, we use the variable name instead and pass it a parameter. So for example, we can say print square 2, and that should display the number 4. Let's save it. Run the code, and there's 4. And so that's really all you need to know. Now, just seeing this example doesn't really show you the proper use of anonymous functions. One place an anonymous function can come in very handy is with the map higher order function that we looked at in the last lesson. So for example, let's comment out this code. Let's go back to the example I gave you in the last lesson. We had a list of numbers, and we wanted to create a new list of those numbers squared. So what I can do right here, instead of going to the trouble of creating the square function, I can just use this anonymous function to square each number in the list. And by doing that, I've saved myself the trouble of having to define square, and I can replace that with this anonymous function and put it in the same location as the first argument to map. So let's display the result to see that it works. We'll save it. Run our code, and there's our numbers squared. There are, of course, more advanced uses of anonymous functions, but they go a bit beyond the scope of this course. So what I'd like to do now is leave the topic of anonymous functions per se and move on to a continuation of what we've started with map, and that's a discussion of higher order functions. And the two others that we're going to look at are filter and reduce, and we might look at map again also. We're going to see those higher order functions in the next lesson.